So this next set of tests is going to be measurement of the AM modulation depth. Start off with the function generator on its default setup. So I'm just going to demonstrate the one channel. So swipe across to give a bit better view of that channel, and I can swipe him up to show the waveform a little bit better. We'll switch on modulation, and since I've already run this test, it's been left at my settings, which is 1 MHz for the carrier frequency, 1 volt peak to peak, and 10 kHz for the AM modulation. And at the moment we'll leave it as a depth of 50%, but I have been moving it through 20, 40, 60, 80 and 100% modulation depth. Now the spectrum analyzer, unlike all the other tests where I'd set this up for a wide span, this is now set up for a very narrow span, and the center frequency has been set to match my frequency of my carrier waveform. And the other aspect that I've done for this is to set this up to quite a high level of averages there to increase the accuracy of this measurement. So we'll put our output on, and you can see all I'm really interested in is the two peaks here that represent the modulated waveform and my carrier frequency here, and it takes a little while for it to settle down because of the number of averages that I'm using. So we'll let him settle. Once he's settled and we've got readings, I've set this up to this amount of time I only need, so it's at 4. It can actually go down to 3 because I'm only interested in two sidebands, and the main carrier I've set it to delta, so it's reading the difference between the two, and I've wound the threshold up so it's somewhere near these anyway. So you can see there's the threshold there, so it's right above any other peak, so I'm just picking up those 3 peaks that are my main points of interest, and you see it's settled down there now. So for this particular reading I've got center frequency on minus 2.95 dBm. I've got the carriers on minus 12.1 dBc. So there's now a calculation based upon those figures that I'll need to go through on the computer, and that will give me a calculation value to compare to the actual measured value. So for those that want a bit more information on the AM signal modulation depth calculation, I've got the information from this document from Siglent, and it goes through the calculations and proves them, and you end up with this formula down here at the bottom that I've used to verify all the measurements against the actual modulation depth setting. And I'll put a link to this document in the description below, so you can go and obtain this and read it at your own leisure. And then once you have this formula here and you want to put it to use, I created this spreadsheet I'm in Mac numbers, and the actual measurements that were all made, these are the measurements here that were all made, and I made it for the AFG31052, the DG1022 and the UTG962 as well for comparison. And there's all kind of plots that you can come out with to look at the data. You can see here, so this is just on the AFG31052, and you can see both channels mimic one another, there's no difference between them. And then the maximum error I got was 0.3% against the actual modulation setting, which was at the 60% mark. And if you wanted to look at the actual differential across the units, you can see the poor DG1022 there, significantly worse than both the UTG962 and the AFG31052. So there's the results. I'll leave them with you. Thanks for watching, and I'll see you in the next video.